Hello everyone, my name is Shopnil. Welcome to my YouTube channel. Today I am going to talk about some topics of NLP. So without wasting any time, let's get straight into the video.
Today I am going to cover the topic Unveiling the World of Natural Language Processing from Text to Insights. So before covering the main topic, we need to know at first what is natural language processing. So natural language processing is a branch of artificial intelligence that focuses on understanding and generate human language. Few importance of natural language processing are uh, facilitates human and computer interaction in a natural and convenient way. It also helps in extracting insights, sentiments, and meaning of large volumes of texts. It empowers applications like chatbot, virtual assistants, and automated language translation. It also helps in fraud detection. How it helps in fraud detection? It analyzes the patterns of the text given in the message and uh, gives the conclusion whether the text is a fraud or not to the user. NLP applications, virtual assistants. Virtual assistants understands our commands and questions and respond to it by giving the correct answer, like Siri, Alexa, and Google Assistants. Language translation converts text from one language to another while preserving the inner meaning of the given text, like Google Translate. Sentiment analysis analyzes text to determine the sentiments, whether it is positive, negative, or neutral. Now, Twitter maximum times uses sentiment analysis. How sentiment analysis is used? So, when a user comments on other user's profile, Twitter uses NLP, that is sentiment analysis, to check whether the comment is a positive or a negative comment. If it is a negative comment and harming the environment of that user, it will automatically delete the comment and block that comment to provide a vivid environment for the other users in the platform. Text summarization. When a large volume of data is given, text is given, and the reader does not has enough time to read the text, he can use text summarization to get the key information from the large volume of data. Information extraction. Information extraction is mainly used in medical fields. So when the prescription or some disease report is given, doctors can use NLP, that is information extraction, to get the informations about the disease and the drugs to be used for the patient to make him or her cure. Before doing NLP, we need to do a series of text pre-processing, because when we get a raw data contains noise and irregularities that can hinge the efficiency of NLP. Text preprocessing is a crucial role to do NLP. So when a raw data is given to the system, we at first remove the noise, and then we use text normalization such as tokenization, lemmatization, stemming, etc. Then the word standardization. After that, a clear text is after that one clear text we get a clear text. That clear text is given to the machine learning model such as RNN model to do the NLP for that given text. What is tokenization? Now, tokenization means breaking down the text into individual words or tokens. Example: natural language processing is fascinating and exclamatory mark. So after doing tokenization, what we get is natural language processing is fascinating exclamatory mark. So that sentence is broken into 6 tokens after using tokenization. One more example of tokenization is natural language processing. So we are breaking that thing into three tokens: natural, language, and processing. So in this way, tokenization work. Stop word removal. Stop word are common words that do not contribute much to the meaning of the text, such as the, is, a, and, over. So one example is, this is a test. So in this sentence, if we remove is and a, it will be this test. Is and a are stop words which does not contribute much to the meaning of the sentence. One more example is, the quick brown fox jumps over the lazy dog. After doing stop word removal, we get quick brown fox jumps lazy dog. So the inner meaning of the sentence is still present, but few words are removed, which are the stop words. Stemming and lemmatization. Stemming is reducing the word to its root form, and lemmatization is reducing the words to their base form. One good example of stemming is running. So when running word is given, after doing stemming, we get the word run. Now, text classification. Text classification is the process of categorization or labeling text documents into classes or categories based on their context. One example is sentiment analysis, as I have told earlier. Like Twitter uses sentiment analysis, so it categorizes the context into positive, negative, or neutral. So when a negative text has been spotted, it automatically bans it so that the environment is not does not become toxic. Spam detection. Identifying unwanted messages is known as spam detection, mostly used in Gmails. So when an unwanted email is sent to a user and Gmail sees that it does not requires, the mail is not important for the user, rather it is a spam mail, it will send to the spam section of the email. Topic categorization. Analyzing topics or categories to documents based on their context, such as news articles categorization by subject. Spam group detection. Identifying and categorization of groups or entities engaged in the spam activities. So, what spam group detection, after spam group detection, what is done is shown in the next page. So, spam group detection, we can see one review database is there. So, from the review database, we remove the not required the spammed images. So after removing the spam reviews by SGD, the non-spam reviews is done sentiment analysis. Then by to help of sentiment analysis, feature extraction is done where, from where the positive reviews are taken into account, and it helps in improve the business models, etc. Named entity recognition. Named entity recognition is a subtrack of NLP that focuses on identifying and classifying named entities in text into predefined categories such as names of persons or organizations, location, expressions of times, quantities, monetary values, percentage, etc. So in the given sentence, we can see we work is an organization. Like from the NLP itself tells that we work is an organization, Adam is a person name, Manhattan is a location, and 37.5 million is a monetary value. Parts of speech tagging. Parts of speech tagging is the process of labeling words in a sentence with their grammatical roles such as noun, verb, adjective, adverb, etc. For example, one sentence is given: Bob made a book collector happy the other day. So Bob is the subject of the sentence, which is the noun. Made is a verb. which comes from make, past tense of make is made. A book collector is an object. So inside a book collector, a is an article, but we know that book is a noun. But collector is also a noun. So book collector, book word is defining the collector. So book becomes adjective. It modifies. Then happy, happy is a adverb, and the other day is the is article, other is adjective, and day is noun. So in this way, one sentence is broken into its parts of speech form to do the NLP. Word embedding. Word embeddings are numerical representation of words in a continuous vector space. Each word is mapped to a higher dimension vectors where words are similar meanings are located closer to each other. For example, word embedding captures semantic relationships between the words. So in the diagram we can see vector space diagram we can see word king and queen are close to each other, and man and woman are also close to each other because king and queen gives the semantic relationship, same semantic relationship, so they are close to each other, and man and woman give same semantic relationship, so they are close to each other. Text similarities and clusterings. Techniques of techniques of measuring text similarities. Various techniques are used to measure the text similarities between the two or more pieces of text. These may include methods like cosine similarity. So cosine similarity is mainly used for text similarity. Clustering of groups, grouping similar documents. Clustering is a technique used to the group similar documents together based on their content. It also helps in organizing and understanding large volumes of data. For example, in the diagram we can see large volumes of documents are given, and the three genres of the documents are technology, entertainment, and sports. So by using text clustering, we can the large volume of document is broken into three genres: technology, entertainment, and sports, and the required genre is selected, and after that NLP could be done. Language models. So language models, GPT-3. One of the most advanced language models developed by OpenAI is GPT-3. It uses a transformer architecture and has a large number of parameters, enabling it to generate highly coherent and contextual appropriate text. But bidirectional encoder representations from transformers. It is another influential language model known for the bidirectional training approach, allows it to efficiently capture context and informations. Architectures and impacts on NLP. GPT-3 employs a transformer architecture with a massive number of layers and attention mechanism, allowing it to generate coherent and contextual relevant text across a wide range of text, but utilizes a bidirectional transformation architecture which enables it to understand context from both left and right of the word. This makes particular effects for the tasks like question answering and sentiment analysis. Text generalization. Text generalization involves the process of automatically producing coherent and contextual relevant pieces of text. This can range from short sentence to entire article stories. Applications like chatbots and content generation. Chatbots are used. A chatbot uses text generalization to interact with the users in a convenient manner. They find applications in the customer service and virtual assistants. Content generation. Content generation. Text generation is used to automatically produce contents for various purposes such as gathering news article, writing product descriptions, and more. Diverse models in NLP. There are mainly three kinds of models: rule-based models, statistical models, and machine learning based models. What is rule-based models? Rule-based NLP system rely on predefined set of rules to process understanding languages. These rules are crafted by linguistics and experts in the field. What are the advantages of rule-based system? Praises control over language processing, easy to interpret and debug, well suited for domains with well-defined linguistic rules. Statistical models. Statistical models in NLP rely on large datasets to infer patterns and relations between words and phrases. Techniques like HMM and CRA fall under this category. Advantages: can adapt to new language patterns efficiently, efficient for the tasks like a part of speech tagging, named entity recognition. Machine learning based approach. Machine learning models includes techniques like support vector machine, naive Bayes operator, and neural networks are used for the NLP tasks. They learn the pattern from the labeled data. Advantages: can handle complex relationships between data, because in neural network RNN is used for mostly text-based natural language processing, which can handle complex text-based data, and relative for tasks like sentiment analysis and text classification. Challenges and future trends in NLP. Current challenges: low resource language. So many NLP models perform well in high resource language with abundant training data, but struggles in the languages having limited textual resources available. Overcoming this challenge is crucial for global NLP applications. So many languages are present in this world where not too much of the dataset is present, and the dataset which are present for that language are too much noisy. So NLP researchers cannot research on those languages. So it is tough for them to do NLP on those languages. So it's a crucial part, crucial challenge for global applicants. Emerging trends. Example: multilingual NLP and explainable NLP. Multilingual NLP: the ability of models to understand and generate text uh, in multiple languages. This is a crucial for applications that needs to process diverse linguistic data. Explainable NLP: ensuring the NLP models provides clear and irreplaceable results. This is especially important for the applications where the decisions need to be justified and understood by the humans. Conclusion: natural language processing has been revolving between the human-machine interaction. We have discussed in this PPT about the NLP components, including pre-processing of the textual raw data, classification, pause tagging, word embedding, and similar and clustering, as well as game-changing models like GPT-3 and BERT. Challenges in handling low-resolution languages were addressed, while emerging trends such as multilingual NLP and explainable NLP. The potential of NLP is boundless, and staying updated on the latest technologies and methods will unlock greater prosperities in this dynamic field. Thank you.